All right, good morning. Uh, I had some requests to make a video to help you with this problem, homework 8, problem 3, which is perfect. So here you have a tank and you have a siphon, and it's sucking water in the tank, going through A, B, and then spitting out at 2. And it wants you to find the pressures at A and B. Okay. Now, what you need to do is you can't find those pressures unless you find the velocities inside the pipe. Okay. Really, what you need to do is the first step is to go from 1 to 2. Okay. So if you do Bernoulli's from point 1 to point 2, so point 1 is the free surface of the water in the tank, point 2 is the exit at this 25 millimeter diameter. Okay. So when you do Bernoulli's, P1 and V1 are 0. Okay. Because it's free surface, it's a large tank. And then I pick my datum at 2, so there's a Z1. P2 is at the free surface, so that's gone. And Z2 is our datum. So really what you have is V2 squared over 2G equals Z1, and you can solve for V2. Okay, that exit velocity. Then you know the area because you know the diameter, so you can solve for the area, and you can then pretty much solve for the flow rate, because guess what? The flow rate at 2 is equal to the flow rate at B, and which is also equal to the flow rate at A, conservation of mass. Okay, so you now know the velocity coming out, you know the flow rate, so now you can find these pressures. So the first thing you want to do is go 1 to A. So P1 over gamma plus V1 squared over 2G plus Z1 equals PA over gamma plus VA squared over 2G plus ZA. Again, free surface at 1, the pressure and the velocity, and my datum, because that's where I pick my datum, okay, for this case, that all goes away. You have a pressure, you have a velocity, and a Z1 and ZA are at the same datum. Okay. Now, the tricky part is you have to find the velocity now, and you know the flow rates are the same, so you can use V dot A equals V dot 2, and you can then solve for VA. Okay, because the area, remember, the diameter got bigger, so the velocity is going to be different. And here is your final equation before you plug your numbers in. You can now solve for PA. Same thing for the pressure at B. Go 1 to B, pick your datum at 1. All of these terms go away on the left, but you're left with every term on the right. You're solving for PB. The velocity at B, because it's the same diameter as the velocity at A. And you know this distance because it gives you that distance, which is y. Okay, and you can now solve for PB. Okay. I hope this helps. You just kind of have to do Bernoulli's at multiple spots and realize, okay, I can't do it here. Keep it and then move on. Okay. Because probably what I would have done was write equations for 1 to A and then 1 to B and realize, okay, I don't have those. Let's try 1 to 2. And then I find, okay, I have the velocity. I can go back and plug and chug. Okay, I hope this helps again. And if you have questions, let me know.